Alright, so I put up 2 pages of things. On the right, the green 1 and 2, I'm going to take care of those. But if you can do those, that proves you're really understanding limits. On the left, we got 3 limits that you should be able to do, and then a squeeze theorem, number 4. So we can start, pause me and we can start from there. Often, when we look at things, we got to think of the left hand and the right hand. So I'm going to go to a single page here. I'm going to get in so we can see this. Now, on the first one, it's really hard to picture what this curve looks like. Outside of, you should see though, when the inside here is positive and this is positive, positive divided by positive is going to be the same number, it's going to be 1. Do you guys agree? And when the inside here is negative, the absolute value is going to make it positive, and the bottom is still going to be negative. Some negative n divided by n is negative 1, or n divided by negative, and it's still negative 1. Question is, where does that happen? Whoops. That happens, I think, at 4, right? Because 4 is undefined. 1, 2, 3, 4. And we have an asymptote. You guys agree? Makes the bottom 0. And then I just plug a value. What do I get if I plug in 0? I get 4 over 4, right? Positive 4 over 4, which is 1. So at 0, I get 1. And then I know that it's an open circle here. It looks like that. Then I try like 5. 4 minus 5 on top is negative 1, which is 1. 4 minus 5 on the bottom is negative 1. 1 divided by negative 1 is negative 1. So this is the graph. So now I can just simply look at it. There's x, there's y. As I come in, the left hand is positive 1, the right hand is negative 1. This limit is undefined. Alright? If I would just change one thing, if I would just change this to a plus sign, after the 4 I'd be asking for the right hand, do we agree? And all of a sudden it goes from being undefined to being negative 1. So again, a lot of this is working on graphs and understanding that portion. I don't know how you would do this problem without doing the graph. Alright? So, there you go. Alright, but if I take away those, it wasn't that I was asking, it was this. Alright, so that one falls to, actually we skipped a bunch of steps. We didn't expand it, there's nothing to expand. We didn't factor it, there's really nothing to factor. We didn't, and so then the next thing was the graph, which is what we did. We can't conjugate one either, and when we start number 2, you can't expand it, you can't factor it, you can multiply by the conjugate, and that's what I'll do. Alright, so again, as annoying as it is, I write it all out. I multiply by the conjugate. Now at this point, I don't know how good you guys are getting at this, but I assume you've been doing all those suggested problems, so I can just skip right to doing this. I multiply the top and bottom by the conjugate of 1 plus the square root of 1 minus x squared. And then what happens, and we know this has to happen, the 1's cancel, and I get a positive x squared. And then the x cancels, so this becomes limit as x goes. Hey Nate, how's my favorite student? You want to go ask him or her? Alright, there you go, that's a joke. Alright, so I get x over 1 plus 1 minus x squared. And all I do is I throw a 0 on the bottom. You guys agree the bottom is some value? Right? It's actually 2. And I put 0 on the top, so this becomes 0 divided by 2. But again, I plug 0 in for x, because that's what it says to do. And I can do that, so it's 0 over 2, which we don't write 0 over 2, we write 0. So this limit is 0. Alright, number 3 on the test is a time sucker. And it's just one of those problems that students you should get in 5 seconds that you never do. Is cosine x, is that a continuous function? Yep. So guess what you just got to do? Plug it in. The cosine of 0. Think of your unit circle. It's 1. Boom. 6 seconds. Move on. This is why it's a time test too, guys. We know that there are 4 types of functions that are continuous. Polynomials, trig, rationals in their domain, and roots in their domain. And if you have a limit in the domain, just plug it in, get a number, and go. So why is it that 2 and 1 had to be worked on? 0 was not in the domain of 2. 4 was not in the domain of 1, right? Otherwise, these were continuous functions. You just plug and go. All right. Last one, squeeze theorem. All right. I got to prove this works. Well, I know for a fact that the range of cosine 1 over x is between 1 and negative 1. Right? We always start in that range. If I'm going to prove this, I start there. But I also know I can multiply all sides of these inequalities by x squared and say, hey, I know that the function cos x squared cosine 1 over x is bound between negative x squared and positive x squared. And to give you a you don't need a picture, but to give it a picture so you got a feel for this, all right? What I've just done, and I won't match the book because I'm not going to take the time to look it up. I don't remember which function f of x, g of x, and h of x is where. But I have just bound my function x squared, I'm going to call f of x. Negative x squared, I'm going to call g of x. That should be on the origin, it's a little off on the board. And then my red function today is this bouncing, and I'll call that h of x. I have just bound h of x between f of x and g of x. Does everybody see that? And that is one of the conditions on the squeeze theorem. All right? And once I can bound the functions this way, if I can prove that the limit as x approaches 0 of g of x is equal to the limit as x approaches 0 of f of x, and that will then allow me, using the squeeze theorem, to say that the limit as x approaches 0 of h of x must be the same. And in this case, these both equal 0, right? They're x squared and negative x squared, 2 polynomials. Boom. So, now we got to make a sentence. All right? So, we better call it squeeze, not sandwich theorem. Your book calls it squeeze. By squeeze theorem, I'll abbreviate theorem with the. By squeeze theorem, since, and maybe I didn't define it, since negative x squared is less than or equal to x squared cosine 1 over x is less than or equal to x squared. And, this is the big one, and the limit, and I'll just write it, limit as x approaches 0 of x negative x squared is equal to the limit as x approaches 0 of x squared equals 0, then the limit as x approaches 0 of what? Of my stuff in between is equal to 0. Let's give Callista a little box on this proof so she feels like it's a good thing, alright? She doesn't like throwing boxes there, but we'll do it anyway. And everybody, I just did a lion's share of what would be on the test for Chapter 2. I've just reviewed a whole bunch of stuff. We're going to do a couple more here, so we're going to pause the video. We're going to go to the new page here. We're going to go to I'll come back to this. I'm just going to get here. So the next 2 problems we're going to do are these, all right? Pause the video. All right, so I went dual page to finish the notes for this class. Also, I threw a 3rd problem on that we're going to handle in this video. Another limit, this time a right-hand limit at the bottom there in red. So we'll go to a single page. And if you are starting to grind 3 plus h out to the 5th power, it will work. But don't do it that way. Does everybody look at 1 and think derivative? You should look at number 1 and think derivative. All right, if you do that, because this is in this format, we we got to make some modifications. You should see that black is like the derivative. So what I really want to do is I want to know what f of x is. So I'm going to group this, get this above. And the problem I have, all right, when I look at this, is I don't know what 243 is. So I take out my handy-dandy calculator, and I take 243 raised to the 1/5 power. All right, I take 243 raised to the 1/5 power. And why do I pick 1/5 instead of like 1/3 or 1/4? Because the power of 5, and I see if something amazing happens. And lo and behold, when I do that, I discover that I can rewrite this as 3 to the 5th over h. And all of a sudden I go, ah, the function f of x here, if you don't see it now, is x to the 5th. You guys see that? So, I'll move this stuff down. I'm just going to write that this is f of x equals x to the 5th. Alright? And then I'm going to write that, hey, I know a is 3, obviously. Everybody, we are doing enough chapter 3 that this is a kind of a hybrid of chapter 2 and chapter 3. My question here would be probably something about the black limit right here. Is it a derivative, yes or no, and why? Alright, maybe not do it out because, or maybe I'd let you use the power rule because I don't want to do the blue limit. I want to do what I know how to do now, which is I'll take the derivative of f prime by using the power rule and call it 5x to the 4th. And if you want me to evaluate it a at 3, how fast can I do it? Well, as fast as I can take 3 to the 4th power times 5 on my calculator, right? Which 81 times 5 is 405? Yeah, right? Somebody check me. 405 going on YouTube forever. It better be right. Everybody, that's the answer. And we should recognize, the big thing coming out of chapter 2 is we have to recognize this is a derivative. You have to say, yeah, bomb's going to 0. It is the format. It is a derivative. It is an instantaneous slope of this time the function x to the 5th at a equals 3. You have to get tying these two facts together. Takes practice, and it is in chapter 2. Alright? Now, the green one and the red one. I'm going to move down the page. Get this a little bigger, give myself some space. These are both handed limits. Now, I will tell you right away, the green one is an infinite continuity. And if you know your parent functions, your mother functions, this problem gets a lot simpler. I recognize this as 1 over x, all right, the reciprocal function. All right, and most of my students here from pre-calculus will hopefully remember this, that this is 1 over x looks like this, the blue. Has an asymptote at 0. So 1 over x plus 5 just shifts this curve 5 to the right. You guys agree? And if I shift that curve 5 to the right, maybe my smart board will let me do it here. There it is. Oh no, what did I say? 5 to the left. I said right, but I meant left. How about I do it the correct way? Let's do it the correct way forever. There we go. I meant left. It's plus 5. Negative 5 makes 0. So I look as I come down the left-hand side, and I see that this approach is negative infinity. All right. The other way to do this problem is you know that you're coming from the left-hand side. What's an x value close to negative 5? How about negative 5.1? You guys agree? And when I take the function and I take x value, I go negative 5.1 and 1 over x plus 5. And I put this in my calculator, I'm going to get 1 over negative 1.1, so I get negative 10. Then if I try negative 5.01, something a little closer, I get negative 100. Then I put in negative 5.001, I get negative 1,000. You guys see how this runs away to negative infinity now? And I'm getting this value right here, this value right here, by plugging this in for x. Just an xy table, all right? That method works also, all right? Now, if I wanted to know if, now obviously this does not have a limit at 5, it's negative 5, do we agree? guys, I screwed up. If it was the limit as x approached 5, it'd be 1/10. I was doing this. I was trying to hurry through here. All right. So this should have been -5 to the -5 side. All right. Let's do the last one here. I think I'm going to move this onto a whole new page so we can talk about it. All right. So we're going to do a limit. First of all, can you plug one in? I haven't checked yet. So if I do this limit, if I plug one into the bottom, nope. Do you guys agree 1 is going to make the bottom 0? So, listen, if it didn't make it 0, it's a rational function. The left hand and right hand would be the same because it'd be continuous, so we'd be done already. All right? So it didn't matter if it's left hand or right hand in that case, but this time it's going to matter, maybe. We'll see. So I'll go 1 plus, and I'll factor. It's x minus 3 over x plus 3, and it's x minus 3 times x, no, x plus 3, x minus 1. Do we agree? I'm sorry. So these cancel, and then all of a sudden you're like, oh crap, Batman, it's still 0. All right? So this is undefined as a limit, but now I'm going to have to do some graphing and some thinking, okay? I'll start by saying, let's do a table. We know at 1 it's undefined. You guys agree? So I'm going to work on 0.9 on one side and 1.1 on the other. You guys with me? And when I put in that, what you want to do is you see what happens to the bottom. Do you guys agree the top's going to be x minus 3 is going to be negative, right? When I put 0.9 in here. And x minus 1 on the bottom is going to be negative 10. Do you guys agree? So when you take negative 2.1 divided by negative 10, you're going to get some big number. You know, it's going to get big. Negative. Like negative 20-ish, okay, approximately. And we know if we go 0.99, it's going to be like negative 200, right? Because the bottom is going to get very small, so that's going to drive up. So this is going towards negative infinity, is what I just showed. On the other side, I tried 1.1. It's still negative here, right? And on the bottom now, it's a positive 1/10. So what's it doing on the other side? It's going to positive infinity. No, gosh, you guys are letting me make mistakes.
Yeah,
The other way. Oh my gosh. Negative positive is a negative. Up to the top, negative negative is what? Positive. I had it backwards. I'm sorry. I'm tired. It's Friday afternoon. Albany's homecoming is happening. They didn't invite me. I'm upset. We'll see if anyone watched the video and mentioned it. All right? All right. So again, now Calista, all you got to decide is which side of 1 am I on? Positive side. So this runs to negative infinity. Your other option is to graph this, okay? Your other option is to graph this.
okay, so like I graphed it earlier on my calculator, so like I don't know what to do. And then I got it, and I'm like, oh, he probably wants for. And I didn't know how to do that.
No, I would take a graph. I would want you to sketch the graph on your test.
Okay.
So that I knew you read it. Because I don't know off the top of my head what this looks like. Exact.
So it's like the middle part.
This is how we do.
Oh,
There you go, finish it.
what? Oh, finish. It's like a little bit like that. But so it's like like up here. Yeah.
Yep. That's what it looks like? Alright. So I'm going to erase the circle. So everybody, x, y, and she just showed that it goes to positive infinity here, negative infinity here, negative infinity here, and positive infinity up here on the vertical asymptotes. And remember, when you have a vertical asymptote, the left hand's and right hand's, right? When you draw this. So when you look at 1 positive, positive infinity. Wait a minute.
Yeah.
You got this back. You sure it wasn't the other way?
I don't know if how my calculator showed it.
Because then I made a math mistake. Because it should look like.
So it's not still my calculator.
Because if it doesn't look like this, the blue, because that's what I came up with. All right, so now we got to check. Maybe I'm screwing up. Tired?
I mean, it could be me, like I said, I'm kind of special.
No, we're all special, and it's late, and I'm what Judah can afford for a math teacher. All right, so.
Mine still came out the same.
So listen, we got a mistake then. If that came out, if your graph looks like the black, not the blue, it is not positive infinity. Negative infinity. It's positive infinity on the black. I mean, so I'm gonna do this here. Make sure I did this. This is how we do. All right, I got my window. Ah, it does not look like that. This has a hole. I'm gonna erase this. This does not look like this. All right, guys. When the x plus 3 cancels, it's not an asymptote at 3. It's a hole at 3. Right? Doesn't even show it there. And then at 1, it looks like this, and the graph looks like this. And it has a horizontal asymptote at 1. We should have saw that immediately here, knowing that we.
Why does my calculator not do the right stuff?
All right, I am gonna guess that you typed it in wrong. And I'm gonna show you how it has to look. You have to have the whole numerator in parentheses.
Yeah, I did.
And the whole denominator.
Yep.
Well then, you gotta have a window of -10 to 10 on both the x and y. See if that fixes it. Because if your calculator, if you type it in, and when you hit graph, it should look like this.
So I may have dropped it on my locker a while ago, so maybe that fixed. It makes it randomized. I like completely broke it for a few minutes.
Oh, maybe a baby will like it then. Okay, so. Yeah, I see that. Hit y equals for me. Show me again. I'm gonna pause the video. Albany, we're gonna check out Callista's phone.